Okay, the standard normal distribution. Although a normal distribution is fully specified by its two parameters, mean and variance, or let's say standard deviation, x is distributed normally with mu and standard deviation. Okay, the first variable is the mean. The second variable is the standard deviation. One normal distribution can differ from another in either its mean value or its standard deviation value. For example, let's assume we have we have two normal distributions. The first one has the mu1 and given sigma, x2 distributed normally with mu2 and a fixed sigma. So this means that, and let's assume mu2 is greater than mu1. So this means, since we have two different normal distribution, the first center, right, because the mean must be in the center, is mu1, and since the mu2 is greater than mu1, this is the second distribution. Okay, so this shows the first distribution, and the second one shows this bell shape shows the second distribution. As you see, they are not the same. Why? Because we have the two different population mean, or it can be differ in their standard deviations. For example, again, let's assume we have the normal distribution. X is distributed normally with the given mu and let's say sigma 1, and x2 is distributed normally with the same mean and but a different standard deviation. And again, let's assume sigma 2 is greater than sigma 1, or let's say sigma 1 is greater than sigma 2. Okay, now this means, okay, now in this case, let's assume this is the mu, and this is the center, and this is for the let's assume this is for the first distribution, normal distribution, mu and sigma 1. Okay, and for the second one, since the mean is the same, so the center must be here, but sigma 2, which shows the variability, is less than the sigma 1, it means that the second distribution might be something like this inside. So this is the case for x2 is distributed normally with the same mean but less standard deviation. Okay, see, again, they are not the same. As you see, they are all different. Or another possibility, let's assume we have x1 is distributed normally with mu 1 and sigma 1, and x2 is distributed again normally with mu 2 and sigma 2. Now we have the different means and different standard deviations. So it can be anything like this, like, okay, the center is different, right? Let's say this is mu 1, and the second distribution, so this is for the first distribution, and second distribution mu is different and sigma is different. This means that the shape, the bell shape curve is totally different than this one, and the centers are also different. Let's assume this is the second one. Let's assume this is the mu 2. Okay? As you see, they all differ. So how are we going to compare two different standard normal curves, two different normal distribution? So since these normal distributions differ in either their mean values or standard deviation values, let us define a new variable. Okay, this new variable is z. Okay, so what is z? Z is known as standard. Why it is standard? Otherwise there is no benchmarking data. Standard normal variable. And a standard normal distribution is standard normal distribution is one whose random variable z always has a mean of 0, means mu equals to 0, and a standard deviation of 1. So sigma equals to 1. Okay? So then we can say that z is distributed normally with a given population mean, which is 0, and a given standard deviation of 1. Okay? So this means that any normally distributed random variable with a given mean and the given variance or standard deviation can be converted to standard normal variable by the transformation formula. So let me write it down. Any normally distributed random variable with a given population mean and standard deviation can be converted to a standard. Why it is standard? Because mu and sigma are fixed, 0 and 1, to a standard normal variable by the transformation formula. So the formula is z equals to x minus mu divided by sigma. Okay? I know everything looks very strange, but mainly the summary here is this is what we are trying to do. Okay, so we have the normal distribution. What is normal distribution? It's a bell-shaped symmetric curve, right? The center is mu, and this normal curve can be represented as x distributed normally with mu and sigma. So you can write it down 1 billion or infinitely different normal distributions, since the mean values and the standard deviation values can be different. So this is the normal distribution. So our target is, in order not to use the strange formula that I gave you, remember the formula that I gave you is, actually, sorry, where was it? Okay, I'm trying to find it. Remember, x is distributed normally. I couldn't find it. Okay, remember, if we don't have the standard normal distribution, then we have to use the probability function. It was f of x equals to 1 over 2 pi times sigma e to the power negative 1 over 2 x minus mu square divided by sigma square, right? So in order not to use this formula for a given normal probability distribution, you have to convert this distribution into a standard normal distribution. So now when you convert everything into a standard normal distribution, now we have the z instead of x. So z is distributed normally with 0 and 1. So now we have the given standard deviation and the mean, and the center is 0, right? So it is fixed. And so this is the standard normal distribution. Standard normal distribution. So in order to convert this into this step, so you have to use this transformation formula, x z equals to x minus mu divided by sigma.